academically speaking or theoretically speaking, what is like the end game of physics?
I think the end game is to construct a framework in which you can um, understand everything, every physical process that we've seen. Whether or not that's possible is up in the air. I don't know if it's possible, and I wouldn't want to be recorded saying it was or not. Um, yeah, I think that's the end game. I think we try to get better and better models for how reality works, and we wonder if there's a framework in which we can unite kind of all physical processes.
And that would be commonly referred to as the theory of everything or the grand unifying theory.
Well, a theory of everything. A grand unifying theory is kind of a subset of that.
Okay.
Where they were looking for, or at least the way I see it is, you're looking for the unification between electroweak theory and the strong force, essentially. So like merging the three forces.
That's grand unifying, right?
Yeah, that's
Okay.
the grand unified theories. There are people talking about trying to merge, build frameworks to merging the three forces in the standard model. So there are four fundamental forces we know of. There's the three in the standard model, and then you have gravity, which is, like we said, from Einstein's perspective, is not actually a force in the sense of it's an apparent force. Yeah.
Okay. Okay. And is it mathematically possible to model everything physically? Like, assuming the theory of everything would mean that you can calculate, and obviously I think you can correct me if you're wrong, you could calculate every particle in the universe with exact precision, right?
No, because that's like a theory of everything that is computationally like possible. I don't know if that's ever going to be the case. Just because what do you use as a computer to compute every particle's position independently? You need a computer that can handle that many bits of information.
Right.
That is the number of particles in the universe. So, yeah, those are different things. I think it's all it's saying, like a theory of everything is really just like a theory where we can, or a mathematical framework. This is another way of looking at it. A mathematical framework that can somehow, on the lower energy scales, which is our everyday, they distill down to the laws we're familiar with. Like, for example, Newton's idea of gravity, one over r squared laws, things like that. They still are very valid models of the way the world works. It's just that once you get to some mass, or like you look for very particular deviations from those laws, that's when you realize you need something new, and that's when Einstein came about and was like, hey, how about we try this other way of looking at it, which is this geometric structure in general relativity. But I think I'm just rambling now. But basically what I guess what I'm trying to say is a theory of everything, it just needs to be self-consistent and has the ability to explain different physical processes well. That's it.
Okay.
Yeah.
And actually, a thought came as I was listening, as you said that the collaborative aspect of physics is not well represented. I think actually Oppenheimer kind of showcased that. It's not very obvious in that, it's about collaboration, but it shows the sheer scale of it. So I guess it's starting to come to light these days.
Yeah.